Hello class, today I just want to go over a few more examples of determining limits graphically and determining limits through a table. So here you see I have two problems right here where we need to find the limit. Determine the following limits using Desmos. I kind of want to show you how Desmos works just to kind of give you a quick rundown of it. So Desmos is an online calculator, graphing calculator, that is very powerful and awesome. And we're going to go ahead and graph these two functions in Desmos and try to determine the limit from that. So here let's start with the top one, and I'm going to go to Desmos. You can go to desmos.com/calculator, and it'll bring you straight here. And I'm not going to put the limit portion in. I just want to graph it, so I'm going to say f of x equals, let's see, I'm going to put it in parentheses, x squared. And to get down, if you notice right now the cursor's in the little exponent, just press right to go down to the main script again. X squared minus x minus 6, close parentheses, divided by, and then open parentheses again, x minus 3. Now the reason I did the parentheses is because I wanted to show that this whole top thing was divided by this whole bottom thing. Otherwise it wouldn't have recognized it. So make sure you're putting it in carefully and correctly. So the limit as x approaches 3, well, let's see. 3 is right here, so it's this point right here. Now, as we approach 3 from the left, it looks like it approaches 5, and as we approach 3 from the right, it looks like it also approaches 5. So this, in this case, the limit as x approaches 3 is equal to 5. Now remember, the left-hand side and the right-hand side must agree in order for the limit to exist, meaning that they have to be the same value, or they have to be approaching the same value. Now let's look at this limit as x approaches 0 of sine x. So I'll show you how to put sine x into the graphing calculator. I'm going to delete this, keep my f of x there, and I'm just going to, if you just press sin, it should read it as sine and then x. And there's my sine function. So let's see the limit as x approaches 0. So coming in from the left, as we get closer to 0, it looks like it approaches it at the y value of 0 right at the origin. And going from the right to the left, it looks like it approaches 0 as well, as y approaches 0 as x approaches 0. So therefore, the limit as x approaches 0 of sine x is equal to 0. Now, fill out the table to determine the following limit. The limit as x approaches 2 of x squared minus 3x divided by x. So I'm not sure if y'all have graphing calculators like this by your side, but I know you guys have phones that you can do the graphing, or not the graphing, the evaluating on. So I'm going to evaluate at all of these points. So I'm going to plug in 1.9 for x, evaluate it, plug in 1.99 for x, evaluate it, and so on. Starting with 1.9, I have x, oh, not x squared, 1.9 squared. Oh, hold on, let's see. I need double parentheses. 1.9 squared minus 3 times 1.9 divided by x, which is just 1.9. And I get negative 1.1. Plugging in 0.99, it's kind of confusing, or it looks confusing when it's on the calculator, doesn't it? Minus 3 times 1.99 divided by 1.99. We get negative 1.01. And then doing the 3 nines, 0.999, we get negative 1.001. Now I'm approaching 2. I'm going to start at 2.1 here and move and work my way left. And I'm sure you guys can see where this is headed. 2.1 squared minus 3 times 2.1 get negative 0.09, or sorry, negative 0.9. Yep. Okay. I get negative 0.99. And then we get negative 0.999. So as we converge upon this 2, as x approaches 2 from the left, it looks like we're getting closer to negative 1. And as x approaches 2 from the right, it looks like we're also approaching negative 1. So what's the limit as x approaches 2 of x squared minus 3x over x? Well, that's just going to be negative 1. And there you have it. I just wanted to go over a few more examples and kind of show you a little bit on Desmos. So get started on the worksheet. Let me know if you have any questions. Have a good one. Bye.